Hello everyone. We want to talk about dot product in the continuation of lectures on vectors. So we have learned how to add and subtract vectors, but multiplying vectors, different story. One way you can multiply vectors is by using dot product. So the symbol is like a dot as it is clear. So vector A dot vector B. That's how we write dot product of two vectors. And it is defined as the magnitude of the first vector times the magnitude of the second vector and times the cosine of the angle in between. So if you have two vectors, let's say vector A and vector B, and these two vectors are drawn tail to tail, and they make an angle of theta, okay, with respect to one another. If that is the case, then if you grab the magnitude of the first vector multiplied by the magnitude of the second vector and times the cosine of the angle in between, that number, that scalar that you get is called the dot product of the two vectors. So as you clearly see, the dot product of two vectors is actually a number. It is a scalar. So if it is a scalar, it means that it could be positive, it could be negative, or it could be even zero, because it is a number, end of the day. And that's why we call this scalar product, actually. Now, sometimes the vectors are given in Cartesian form. Let's say A1, comma A2, and B1, comma B2. Sometimes the vectors are in Cartesian or algebraic form, and in that case, the dot product of the two vectors can be defined as the expression A1 B1 plus A2 B2. And this, of course, can be proved, but considering the circumstances, we don't have time to prove the formula, but that's what it is. It's also in the textbook. You can easily read that. So the dot product has this definition. If you have the magnitude of the two vectors, you multiply them and times the cosine of the angle on condition that the vectors are tail to tail. And this angle theta could be obtuse or it could be acute angle. In other words, theta is between 0 and 180 degrees, needless to say. And if the vectors are given in Cartesian form, you multiply the first components and add it with the product of the second components. A1, B1 plus A2, B2 would be the dot product of the two vectors. Now, if the two vectors are parallel, let's say, you can have the two vectors parallel. If you draw them tail to tail, they will be actually collinear vectors having the same extension. In that case, if they are parallel, obviously the angle that they're making with one another is 0 because they're parallel, and cosine of 0 happens to be 1. So in that case, A dot B becomes magnitude of A times magnitude of B times the cosine of 0, which is 1. But if they are perpendicular, then you know that cosine of 90 is 0. So cosine of 90 is 0. 0 times anything is 0. So the dot product of the two vectors is going to be 0 if the two vectors are perpendicular. And this is an extremely important property. I hope you're going to remember that. Other properties of dot product are the following. If you interchange the order, A dot B is the same as B dot A. So basically, the dot product of two vectors is commutative. It has the commutative property. It also has the associative property. So if you have K times vector A dot vector B, and K is of course a scalar, you can just find the dot product first and then multiply the answer by K. So it's associative. And you can also find the dot product of A with k times vector B. And other than commutative and associative properties, it also has distributive property. So if you have three vectors and A dot B plus C, that would be A dot B actually plus A dot C. So this is another property. And K is a real number. It's a constant. It can be positive, negative, or zero. And the other property, distributive property, is for three vectors, A, B, and C. And if you find the dot product of any vector with itself, think about it, the angle that any vector makes with itself is 0, and cosine of 0 is 1. So you end up with magnitude of A times magnitude of A, again, times cosine of 0. And that will be magnitude of A squared, basically, okay? So that is the dot product of a vector with itself, actually. And these are some important properties. So just to give you an example, if magnitude of this vector A is like 4 units and magnitude of B is like 8 units, and the two make an angle of 60 degrees with respect to one another, then in that case, A dot B would be magnitude of the first, which is 4 times 8 times cosine of 60 degrees. So that's 32. Cosine of 60 is 1/2. We can use the calculator, and the answer is, of course, 16. So A dot B is equal to 16. And as I said, the answer to the dot product is, of course, a scalar or a number. Okay, and I can give you another example. We have a vector A whose magnitude is 120, vector B 150, and they're making an angle of 90 degrees. Okay, so if that is the case, they're making a 90-degree angle. So A dot B would be 120 times 150 times cosine of 90. So we knew from before, if two vectors are perpendicular, their dot product is 0. That was the most important property of dot products. Okay, so here, again, 120 times 150 could be whatever, but when you multiply it by a 0, it gives you 0. So the dot product is 0. Sometimes the answer is actually a negative number because a dot product, end of the day, is a scalar, as I said. I can give you other examples. For example, let me erase part of this. Let me erase this top part. So we have vector u, 2, negative 3, vector v, 3, negative 2, and we want to find u dot v. Okay, so we're going to use the property I mentioned earlier. It's going to be 2 comma negative 3 dot 3 comma negative 2. So 2 times 3 plus negative 3 times negative 2. Okay, so that's 6 plus 6, and that is 12. So the dot product of these two vectors is 12. Now, if it was 0, I would know that the two vectors are perpendicular. Okay, so this was the story of dot product and its properties, and we just have to keep practicing and do a variety of questions to learn more about dot product.